Thank you so much, Bobby. Hi, everybody. It's great to see. I do see some familiar names in the participants list here, in the attendees list. It's great to see everyone virtually. I want to thank Bobby, Andrew, Pace, Juice, everyone here at ADC for having us. My name is Greg Chin. I am the audio evangelist for Avid. I've been here 14 years. And I'm really excited to be here to talk a little bit about Pro Tools Carbon. So obviously this is a developers conference, and you might be thinking, well, I mean, if you don't already know, we did launch Carbon last week, but you might be thinking, what does this piece of hardware have to do with me as a developer? Possibly creating plugins and such. Well, actually, quite a great deal. So I'm going to give a little kind of a high level, quick overview of Carbon and what that is exactly, and what's included. And then Rob Majors is actually going to do all the main heavy lifting and talk a little bit about the AAX plugin platform and a couple of things there. And that does kind of sort in a sense tie back to Carbon here. So. And then also Ed Gray's here, as Bobby mentioned earlier, and he'll talk a little bit about joining us on your AAX plugin journey with Avid. So without further ado, let me jump right into it. Of course, please do feel free to ask questions here in the chat. I'll either, I think we have a couple of minutes at the end for some Q&A. We can bring some stuff up, but of course, while things are going, myself, Rob, Ed, we can answer some of these questions in the chat as things are going. So don't be afraid. Go ahead. It's not going to bother me if you ask some questions here as we go along, and I'll try to monitor it here best as I can. So jumping right into it, what exactly is Carbon? Well, Carbon is a brand new audio interface that we launched last Thursday. It is kind of a new paradigm for us here at Avid. Up until now, if you wanted to leverage our digital signal processing platform, or HDX platform, that was done via HDX. There was really no other way to get in there. But with Pro Tools Carbon, we've kind of created what we call a hybrid production audio system, and it really is kind of meant. We created it with musicians. We're a bunch of musicians here at Avid on the audio side, and we wanted to create an audio interface that kind of captures a lot of the goodness of DSP acceleration from HDX and actually put it in the box, in the audio interface itself. Obviously, it's not an entire full HDX card. I'll talk a little bit about that in a little bit, but that's essentially what it is in a nutshell. So who is it for? Well, it's pretty much for anyone who wants to record music and be able to capture performance with the best possible quality and timing in the most efficient way possible. We want to make sure that the creator has the ability to work natively, but also harness the power of DSP, right? So low latency is extremely important. We want to make sure that the user has the ability to be able to track, record, do things like overdubs with the least amount of latency possible, and that's where our DSP technology kind of comes in. Of course, being able to do things like cue mixes, setting things up quickly and efficiently. We want to be able to make sure that this box it enables the user to get in and do what they need quickly between hardware and software. So taking a quick look at what comes with Pro Tools Carbon as far as plugins, you're getting, of course, you're getting Pro Tools software. So you are getting Pro Tools, not Pro Tools Ultimate. Carbon does run its DSP functions and what we call the hybrid engine using Pro Tools. So Pro Tools, some of you might know it as Pro Tools Standard or Pro Tools Vanilla, which I absolutely hate that anyone calls it that. But so that does ship with it. So if you are a current subscriber, you can actually use that code to extend your current subscription, whether you're on Pro Tools, regular Pro Tools or even Pro Tools Ultimate. But if you're a brand new customer, this gives you a year subscription into Pro Tools. So you're getting all of those plugins. And additionally, you're getting all of these other third-party plugins from Brainworks, McDSP, Arturia, company Embody, which is a newer company to a lot of folks. They've created something called an Immerse Virtual Studio, which allows you to use headphones and a profile of your ear using HRTF to be able to monitor in different environments. UVI has given us the Model D piano via Falcon. And again, you're getting the Avid complete plugin bundle with your Pro Tools license as well as Heat. So you'll notice that some of these plugins are DSP specific. So all of the plugin alliance stuff that you're getting with Carbon as well as the McDSP stuff are all both native and DSP. So that's what's kind of in the box as far as software and plugins. Now we're leveraging AVB for the connectivity of Carbon with the computer. So why did we choose AVB? Obviously, some of you may be familiar with our matrix. Obviously, we're leveraging Dante in other places as well. So we actually wanted to use AVB here. So we've got some really great functionality and usage on our live sound. So if you're familiar with our Venue line of products, AVB is something we've been leveraging there for a while now and working out really well. And it's an open format. You know, it's a great standard used by us, Apple, and other companies. And it gives us the ability to actually think about what we not just want to do with Carbon today, but moving forward and moving into the future, some of the things that we're able to do. So we've actually been able to actually even craft some of the functionality in Carbon around AVB, today with what we've been able to use on the AVB stack. So as far as a requirement, it does require currently today an Apple Mac computer with a Thunderbolt port at least, running Mac OS Catalina 10.15.7 actually. 10.15.6 is working, but we haven't officially qualified it. So it's really 10.15.7, an available onboard Ethernet or an approved Thunderbolt Ethernet adapter. And of course, you're going to need to be using Pro Tools 20.11 or higher. So 20.20.11 shipped, was released last Thursday, the same exact time as Carbon. So taking a trip down what's in the hardware. So we're using some really great 32-bit 192 kilohertz conversion with 126 decibels of dynamic range, which is great. We've got a padless design on the inputs. We're utilizing JetPLL, double resolution JetPLL for the clock, which offers extremely low jitter. We've got something called variable Z inputs, which automatically will optimize the impedance of the mic or instrument on the input. So depending on what you plug in, variable Z will basically kind of switch and give you the correct amount of impedance. And switching power supply is integrated into the unit, not the sexiest thing, but of course, in practice, being able to utilize the unit in different ways, maybe moving it around, that certainly makes things very convenient. Moving to the back of the unit, taking a look at what this unit has available to it. We've got 8 transparent mic pre's, 2 instrument inputs on the front, actually, 8 analog line inputs via TRS or DB25, and as well as 8 analog line outputs also via a DB25 connection. Of course, the AVB connector, 16 channels of ADAT. Of course, we've got word clock I/O, and then back on the front, we've got 4 headphone and monitor inputs. Okay, so let's see what else. This kind of goes over a little bit of some of the impedance switching, how that works. We've wanted to make sure that we, with variable Z, we wanted to make sure that we give some visual indication as well to the user. So depending on what impedance you're on, you will actually get a different color on the input button, as it were. Again, very kind of smart, thinking, same thing with the headphone inputs. If let me just run back one step here. Depending on how many of those outputs you're using, going between inputs and outputs, if you've got something plugged in, it'll recognize it and will give you access to that. If you don't have anything plugged in, let's say 2, 3, or 4, you won't have access. But once you actually plug in a headphone or plug in an adapter, it'll actually become basically live. Okay, so again, we wanted some kind of smart functionality there, to make it really easy on the user. So again, 4 headphone outputs. We also have a foot switch input, which is assignable to, for the Talkback. We do have a Talkback available. You can see that little dot directly to the right of the second instrument input. So you do have Talkback available. And as well as a trigger switch right there on the unit. And all of this, you can actually allocate all your monitoring, headphones, and everything can be assigned directly in Pro Tools. So there's not another layer, another application you actually have to deal with. You're doing all of that work directly in Pro Tools. So what does this actually mean to you as a developer or a possible developer? Well, this unit, again, we're utilizing something called the hybrid engine, which kind of gives you the best of both worlds, so native and DSP. And for a lot of our customers and a lot of users, this is going to be their first foray into a DSP technology. So Carbon comes in at a price point that is going to allow a lot more users access to be able to leverage DSP plugins. So in our case, obviously AAX. So we do have support coming for this hybrid engine at some point next year. So it's not just going to be for Carbon users. We look forward to that. But again, I think the main idea here for you guys, as far as my part of the presentation here, is knowing that a lot more users are going to have access to AAX DSP. So that's a kind of a quick overview of Carbon, and I hope I'll go back here and start answering some questions as I turn it over now to Mr. Rob Majors. Rob.
Great, thanks a lot, Greg. And you guys, while I'm giving my presentation here, definitely take advantage of the fact that Greg is on the line answering questions. He's a fantastic resource if you have any product-related questions about Carbon or just Pro Tools in general. He's the guy, and you have him on the line right now. So definitely take advantage of that. All right, so I'm going to go into my segment of the talk here. It's an extremely compressed version of what is an AAX plugin, what is an AAX DSP plugin. What do we mean when we talk about that? When we say that Carbon is enhanced with onboard DSP, then what do we mean? So it's the very, very, very fast edition of AAX. And mostly this is targeted at people, those of you who are plugin developers, if you want to know more about what AAX is and what AAX DSP is, or really for anyone else who's interested in what's going on inside of a plugin, and particularly inside of an AAX plugin. So I'm going to run through a few basic points in today's presentation. Again, it's going to be high level. What is AAX? What is AAX DSP? And how do you do it? AAX is Avid's audio plugin format. There are obviously a number of different formats in the world. The most common ones are AAX, VST, and audio units. So AAX is kind of a peer of those other formats in terms of structural ways that you can build an audio plugin, audio processor that gets integrated into things like DAWs. When we say AAX DSP, this can be a confusing term, particularly for people who are DSP engineers, because this is more of a product term for Avid rather than indicating that these are the plugins that have digital signal processing inside of them. Pretty much, all plugins have digital signal processing inside of them. But when we say DSP, we mean the DSP chips, the DSP silicon that is present on Avid's embedded products like Pro Tools HDX and our live sound products in the past, and now in Pro Tools Carbon. Okay, so what's inside of AAX? At the very basic level, an AAX plugin is composed of 4 different components. These 4 components, some of them are kind of object graph components, and some of them are just pure callbacks. So I'm going to start at the top left. The data model is the core of a plugin. We call it the data model or the parameters model. Really, it's the business logic or the domain of the plugin. It stores the state, everything interacts with it, state changes come in, and it propagates them out to the rest of the components. Moving over to the GUI, in an AAX plugin, we don't separate officially a view of the GUI and a controller aspect. I think that's common with pretty much any program. That GUI it represents a controller. Somebody can turn a knob on the screen. It'll update the data model, and then the GUI presentation layer will update. So those top 2, the data model, the GUI, or the domain, and the presentation. That's common to pretty much any plugin or really any program that you'll ever write. Down on the bottom, we have two components which are more specific to AAX. There's a description, which is a single callback that gets called. It's kind of part of the binary interface. It's really the initial binary interface of the plugin. It's the first thing that the host will call, and it tells the host about object factories and how to build the object graph of the rest of the plugin, and also where to locate the algorithm component. So description it kind of sits on its own initially to let the host wire everything up so that Pro Tools, for example, can show that a plugin supports 5.1 and you can instantiate it as a multi-channel plugin on your 5.1 track, and other aspects of like what Pro Tools needs to do when the plugin actually gets instantiated. And then finally, we get to the algorithm, which is in red down there on the lower right. And that's really going to be most of what we're talking about for the rest of the presentation. The algorithm is obviously the core functionality from a user's perspective of what they want the plugin to do. In an AAX plugin, and the algorithm is separated off from the domain logic. And that's intentional. And it's intentional partly because we identified a need for running algorithms in different processing environments. So an algorithm in the AX plugin is purely a callback. It doesn't even own its own memory. Every time it gets called, it receives a structure which provides all of the information that it needs to execute a single buffer of processing. It provides input audio, output audio, private memory, which is owned by the host, but which the algorithm has access to and can write to and then access the next time it gets called, as well as coefficient data that's coming in from the data model. So if we wire that all together, we see something like this. This is, again, super simplified version, but basically the control flow involves let's focus on the algorithm. The description part of the plugin configures the algorithm or tells the host how to call this algorithm and provide it with information every time that it's called. And the data model, as the data model changes, it posts updates. It posts updates to the host, and the host figures that out, synchronizes the information, delivers it to the algorithm at exactly the right moment so that automation plays back in time, so that the algorithm is running on a different thread than everything else on the real-time thread. Often the algorithm doesn't have to worry about any kind of thread synchronization because it just gets called with all the information that it needs. It knows that all the memory it has access to is completely protected. It just runs, does its work, provides the audio, fills the audio, output audio buffers, and proceeds. So that's how AX works. That's how AX is designed. When you add in an embedded algorithm to an AX plugin, by design, all you have to do is recompile that isolated algorithm callback from the same code, same C++ code as you were using before for your native callback, and describe to the host and say, now I support AX DSP. And you're good to go. You build this little tiny library that'll run on the DSP chips, or maybe not so tiny, but a library out of that algorithm callback that it's going to run on the DSP chip. You build it from the same code. So all of Avid's AX DSP plugins work this way, and this is why we're able to take something like Pro Tools Carbon, where you can use DSP mode, and it'll sound exactly the same when you swap a track into DSP mode. Basically, the host just takes away one native algorithm, puts a DSP algorithm in its place, and it's compiled from the same code. It will phase cancel if you were to take the two signals and invert one and cancel them out with each other. And it means that you can pick up your whole session, move it to a different place that is only a native environment. And again, you're running just the same algorithm logic in that environment as well. So that is AX, as the architects intend it to be. So now let's take a step back. So that's kind of pure AX. A lot of you, if you develop plugins, probably don't write pure AX. Probably what you do is you write a plugin using Juice or another cross-format framework, but I'll focus on Juice. It's extremely common. It's extremely clever. It's very, very helpful. If I was, starting to build a plugin today, that's what I would use. So if we look inside of an AX plugin that's built for Juice, it looks basically like this. Okay, again, very simplified, but you're going to write some code. Use my cursor here. You're going to write some code, and your code is not AAX plugin code. You are abstracted from the AAX plugin format because you should be, because you want to write code that works for VST and audio units, AAX, all the different formats. So you write code against this framework API, and you write code to a specific shape and a specific set of components and collection and object graph, which is dictated by the framework. You write a Juice plugin, and Juice does all the work to make it be an AAX plugin. Inside of Juice, there's some specific framework support. This is for AAX. There's also support for the other formats that Juice supports. Okay, so let's take a look at what the host sees, what the AAX plugin host sees when you use a Juice plugin. The AAX host doesn't know about your code, doesn't know about these purple rectangles. All it knows about are these 4 AAX components. And there's a difference here. So inside of a Juice plugin, there is your algorithm, your data model, your GUI, and everything else. But because it makes a lot more sense to do it this way when you are building for the other native formats, the native only formats, VST, audio units, other things, the shape of those formats looks a lot more like this. There is no separate algorithm. So what we do is we basically, the algorithm in what we call a monolithic plugin like this, the algorithm receives a pointer back to the data model, back to the object graph, and it becomes a part of the object graph. Then you have to worry about things like thread synchronization. You have to worry about applying automation at the right moment, not just when it comes into the data model, because that could be a different moment than the audio that's being processed at the time. You have to worry about some other sets of problems, but it's convenient for a framework developer because this kind of matches the shape of other formats that are purely native. So then you bring along your embedded algorithm, but it's in a different memory space. It can't follow the pointer into the data model. You can't just build that algorithm for an embedded platform because it's not an embedded part of the data model. It's running on an HDX card or a Pro Tools Carbon. So how do we solve that? So there's a solution to this. I think that let me check my time somehow. I'll jump ahead here a little bit, but basically there is a solution to this problem if you would like to build an AX DSP plugin, which is also a Juice plugin, take advantage of all the cross-format support in Juice, but also support AX DSP, which doesn't happen kind of out of the box with something like Juice. Currently, today, it'd be awesome if it did in the future. Basically, what you can do is instead of taking the model where you're just taking exactly the same code and compiling it for native or for embedded, like that idealized and the version that AX plugins built by Avid use, you can write your own code, write your own algorithm for an embedded environment for the TI DSP processors on our products, and you can wire it into your plugin and it'll work just fine. So let's see how that works. So taking a look again kind of at the Juice world here, you've got your algorithm that you want to incorporate over on the side. What you would like to do is have the internal components of the framework support update and configure the embedded algorithm. But this is generic logic here. It doesn't know, and you don't want to have to patch the framework every time you build a new plugin. It doesn't know how to follow these arrows, so to speak. So it does require building a few extra pieces. Essentially, what you can do is patch the framework AX support to provide a generic entry point, a generic way to customize for each one of the plugins you want to build. So it's a small patch that allows you to inject something like a delegate to each of these components that does exist inside of Juice for generic components and say, have you provided this delegate? If so, follow it, provide some customization to the behavior, and then proceed with doing the normal Juice generic plugin handling, and then everything would be fine. And then one kind of cool thing is once you've done that, you actually can use that algorithm also for the native plugin that you've built and get all the benefits of having a protected memory for the algorithm, not having to deal with thread synchronization, getting accurate automation playback, and lots of other benefits of the kind of pure AX structure, while also getting benefits from being able to write a Juice plugin over here and applying that to all the different formats you want to support. Okay, so that's extremely high level. Are you ready to get started with it? Then you can go take a look at our example plugin that I wrote a couple of years ago that demonstrates exactly this, and see the way that I went about it when I created that example plugin. There's probably a better way to do it, even than you can take a look at my example and then improve upon it. If you're not an AX developer, you can go to developer.avid.com it's a whole list of all the toolkits and frameworks that we support as Avid. There are lots of different things there. AAX is one of them. Click on the links and follow them to sign up as a developer. If you have any technical questions, you can contact us at devservices@avid.com. And so now to talk more about Avid's partnering programs, which is what you'll reach as you contact that address, I'm going to turn it over to Ed Gray, who's our director of partnering.
Hi, can you hear me, by the way?
Yes, we can hear you.
Good. Hi, everyone. As Rob said, I'm Ed Gray. I just want to thank these two guys, heroes of mine, Greg for fighting the good fight and telling the world about Carbon, which we just released last week, and just this unstoppable force and communicating to people about it. And Rob Majors, who is a modest guy, but for many intents and purposes, helped write the AAX specification and is part of its continuous maintenance and improvement and helping developers. So again, two important figures in your journey. So I just want to shout from the mountaintops to this audience and to everyone at ADC. We want you and we want your plugins. And so you should please follow Rob's advice. Just go to developer.avid.com and download the toolkit. There's no charge to being a developer. We are not a monolith. We communicate and email back and forth with people. We'll give you licenses and debuggable builds of Pro Tools to help you on your journey. And the market for Pro Tools is large and growing. So if you've got a plugin that sounds wonderful and solves a problem and is unique, there's a market and a business for you and all sorts of opportunities for you to create plugins that have never been invented before or never been tried before. And so we want you to have a go at it, and we're all here to help. And Carbon is a big part of this, and Carbon will multiply the opportunity for AAX DSP plugins. And if you really want to distinguish a plugin and have it work also with our accelerated platforms, you have Carbon now in addition to Pro Tools HDX and our Venue Live Sound platform. So the documentation for making AAX DSP plugins is all in there and is robust, and we are real live people here to help. So we want you to join us and write to us with any questions, and we just really appreciate your joining us, and we appreciate Bobby and the folks at Pace and Juice for inviting us to present at this conference.